Today we will be teaching you how to determine the limiting reagent of a chemical reaction. To begin, you should know the definition of a limiting reagent. A limiting reagent in a chemical reaction is the substance which is totally consumed when the chemical reaction is complete. Let's start off by using a simple, real-world example of how the limiting reagent works. Let's say you decide to throw a surprise birthday party for your best friend James. 10 of your closest friends arrive expecting food. You now have to go to the grocery store down the street to pick up hamburgers for all of them. Once you arrive back home, you open the bag of hamburgers and realize after counting that you have a total of 9 hamburgers. You begin to hand out the hamburgers to all of your friends, each person getting 1. Looks like you forgot to get someone a hamburger. Poor James. In the end, because you had more people than hamburgers, the hamburgers are the limiting reagents and the party guests are the excess reagents. Now we can apply what we have learned to an actual chemical reaction problem. This problem is asking us to calculate the mass of magnesium oxide possible if 2.4 grams of magnesium reacts with 10 grams of oxygen gas. In step 1, we need to write the chemical equation for the reaction.
The chemical equation is magnesium solid plus oxygen gas, which yields magnesium oxide solid. It is important to make sure that your chemical equation is balanced before moving on to the next step. A helpful tip would be to write down the information that is given to you in the problem. We have 2.4 grams of magnesium, 10 grams of oxygen, and we need to find how much magnesium oxide we can produce. Step 2 is converting mass to moles of magnesium. We did this by taking the given 2.4 grams and dividing that by the magnesium molar mass, which is 24.31 gram per mole. Step 3 is stoichiometry. Using stoichiometry, we multiply the 2:2 molar ratio of magnesium and magnesium oxide, then we multiply by the molar mass of magnesium oxide, which is 40.31 gram per mole, which gives us 3.98 grams of magnesium oxide. Now repeat the steps 2 to 4 with the given information from oxygen gas. Use given 10 grams of oxygen gas and divide it by its molar mass, which is 32 grams of oxygen. Using stoichiometry, we multiply by the 2:1 molar ratio of oxygen and magnesium oxide. Continue by multiplying the molar mass of magnesium oxide, which again is 40.31 gram per mole, which gives us 25.2 grams of magnesium oxide. Now look at the results to find the limiting reagent. In the reaction, 2.4 grams of magnesium produced 3.98 grams of magnesium oxide, and 10 grams of oxygen gas produced 25.2 grams of magnesium oxide. From this, we can conclude that magnesium is the limiting reagent because it can only produce 3.98 grams of magnesium oxide, while oxygen is the excess reagent because it can produce 25.2 grams of magnesium oxide.
Thanks for watching!
See you next time! created using Powtoon.